Hi, I'm Lauren White. In this lesson, we'll talk together about how to prioritize the substituents on a chiral carbon. Now, given that we have a molecule where we have identified that it does in fact have at least one chiral carbon, we can determine the configuration of atoms in that molecule. The first step to determining that configuration, though, is to prioritize the substituents. So how do we do that? Well, it's all about atomic mass. So grab a periodic table, have it handy, and let's go through some examples to talk about this. Let's start with A. We want to order the groups that are attached to this carbon. So let's write down what they are. We know we have a chlorine, we have a bromine, we have a fluorine, and a hydrogen. And the way we order them, you can kind of think about like an elementary school Halloween party. If there's a bowl of candy and there are no teachers around, which kid is most likely to get what they want? Well, the biggest kid, right? He's likely to just walk over and take his candy. It's the same kind of idea here. The biggest atom gets the highest priority. So we just order them by their atomic mass. Now, you'll get used to the atoms that we commonly see as substituents on chiral carbons, and you won't always have to look these up on a periodic table. But starting out, it's always good to have it handy. So we'll just show the section that we need. Of our atoms, bromine is about 80 atomic mass units. Fluorine then is about 19, chlorine is about 35, and hydrogen, not shown on here, but you should know, hydrogen is just 1 atomic mass unit. Now we just have to number these in order of biggest to smallest. So bromine is the largest, followed by chlorine, fluorine would be 3rd, and hydrogen would be 4th. All right, let's look at part B. Now, the first thing I want you to notice is that we have substituent groups that have more than one atom in them. And an important rule for determining the priority of substituents is we only look at the very first atom connected to that chiral carbon. So, of course, we're talking about chlorine in the top right. We're talking about oxygen in the bottom right. We're not worried about that hydrogen right now. And then we look at the hydrogen connected directly to our chiral carbon. And then in this top left group, we're only worried about this carbon attached directly to the chiral carbon. All right, let's use our periodic table. We know chlorine, we said, is about 35 atomic mass units. Oxygen is about 16 atomic mass units. Hydrogen we know is 1, and carbon is about 12. Great, let's number them. Chlorine is the largest, it's priority 1. Then oxygen is 16, so it's priority 2. Our ethyl group on the top left starts with a carbon, which is 3rd priority, and then we have our hydrogen, which is 4th. Now, you're probably noticing a trend at this point. If a hydrogen is present, it is always the lowest priority group because, well, it's the smallest atom on the periodic table, right? All right, let's do one more. Again, we're only concerned about the atoms connected directly to that chiral carbon. So we're looking at oxygen, we're looking at bromine, we're looking at nitrogen, and then a carbon down here in the bottom left. All right, we said oxygen is about 16, bromine's about 80, nitrogen is, on our periodic table, about 14, and carbon is about 12. So let's number them. Bromine is still first, then we have oxygen, then we have our nitrogen, then we have our carbon group. So in this case, we don't have a hydrogen present. Our lowest priority group is still the one with the lowest atomic mass, and so the methyl group is our lowest priority. Now, you should feel more comfortable assigning the priorities to substituents that are attached to a chiral carbon.